A new dawn breaks on the battlefield, but with it, a shadow. The skies above are not just pathways for traditional aircraft anymore. They are highways for an evolving, asymmetric threat, fleets of autonomous drones, swarming with unprecedented numbers, and projectiles moving at speeds once thought unimaginable. Hypersonic missiles, silent and swift, slip through our conventional defenses, leaving little time to react. The nature of aerial warfare is shifting, demanding a response far beyond what we currently possess. A new paradigm is needed. But what could possibly stand against such a tide? Consider the economics of deterrence. Our premier interceptor missiles, pillars of air defense for decades, cost millions of dollars each. They are designed to bring down high-value targets, sophisticated aircraft, or precision-guided munitions. But what happens when the enemy sends not one, but hundreds of targets? Or thousands? What if each incoming threat costs a mere fraction of your defensive response? The math quickly becomes impossible. A single, traditional missile launch to counter a swarm of cheap drones is not just inefficient, it's a financial suicide mission. This imbalance is the silent killer of conventional defense strategies. The numbers speak for themselves. In 2024, the Pentagon's budget surged to an astonishing $886 billion. Yet, even with such vast resources, the calculus of defense against cheap, mass-produced threats remains a stark dilemma. Every dollar spent on an interceptor missile is a dollar not spent on other critical needs. The current model is not just unsustainable, it's a vulnerability waiting to be exploited. Can any nation truly afford to defend itself indefinitely against an adversary that weaponizes sheer volume at minimal cost? The answer, increasingly, seems to be no. A new approach is not merely desirable, it is essential. But what if the future of air defense isn't about projectiles at all? What if it's about something intangible, yet overwhelmingly powerful? Imagine an invisible wall, an energy barrier that can neutralize threats not through explosive impact, but through a silent, unseen force. This isn't science fiction. It's the burgeoning reality of high-power microwave, or HPM, systems. The Pentagon, in its quest to re-engineer air defense, is quietly turning to directed energy. It's a technology that promises to flip the script, turning the tables on the asymmetric threat and potentially changing the very rules of engagement in the air. At the core of HPM technology lies an advantage that traditional kinetics can only dream of: speed. High-power microwaves move at the speed of light. There is no travel time, no ballistic trajectory to calculate. When a threat is detected, the response is virtually instantaneous. This fundamental difference eliminates the critical delays inherent in launching, guiding, and intercepting traditional missiles. For hypersonic threats that close distances in mere seconds, or drone swarms that overwhelm by sheer velocity, the ability to react at light speed isn't just an improvement, it's the only viable answer. It creates a defense with no escape. How does this invisible wall actually work? Unlike traditional interceptors that rely on explosive force, HPM systems deliver a concentrated burst of electromagnetic energy. This isn't about blowing things up. It's far more insidious. This directed energy bypasses the physical casing of an incoming drone or missile, targeting its very brain, the delicate microchips. Within milliseconds, this intense microwave energy induces currents that overload and fry the sensitive electronic components, rendering the threat inert. A silent, non-kinetic kill. The projectile doesn't detonate, it simply ceases to function, falling harmlessly from the sky. The vulnerability lies deep within every modern electronic system. All drones, all guided missiles, depend on intricate circuits built around complementary metal oxide semiconductor, or CMOS, transistors. These tiny marvels, the building blocks of microchips, are incredibly efficient but also incredibly fragile to targeted energy. An HPM system exploits this inherent weakness. By delivering a precise, high-power pulse, it overwhelms the CMOS, causing a rapid, irreversible breakdown. It's like sending an electrical tsunami through the delicate wiring of a brain. The system doesn't stand a chance. It's a fundamental vulnerability across nearly all modern technology. Such precise destruction demands extraordinary power. HPM systems are not just sending out weak signals, they are engineered for pulsed power. This technology enables the rapid discharge of massive amounts of stored electrical energy in incredibly short bursts. We're talking thousands of amperes, generating gigawatts of instantaneous power. This is the difference between a gentle radio wave and a shock wave capable of overwhelming electronic defenses. This concentrated, fleeting burst is meticulously controlled, designed to deliver its destructive payload directly into the circuits of the enemy, and then instantly vanish, ready for the next shot. But what about distance? How far can this invisible wall extend? Current HPM prototypes are demonstrating effective ranges of up to 10 kilometers. This might not sound like the intercontinental reach of ballistic missiles, but for air defense, it's a game changer. Imagine a protective dome, 10 kilometers in radius, instantaneously neutralizing threats. This range is sufficient to protect critical assets, forward operating bases, or even naval vessels from immediate aerial threats. And remember, the shot is not a slow-moving projectile, it's a speed-of-light pulse, delivering its destructive energy almost instantly within that entire engagement envelope. Here lies perhaps the most revolutionary aspect: reusability. Traditional missile defense systems are finite. Each interceptor fired is one less in the magazine. HPM systems, however, draw their power from an onboard generator, capable of being replenished as long as fuel is available. This means an effectively unlimited magazine. No reloading, no logistical resupply of expensive projectiles. Once deployed, an HPM system can fire shot after shot, pulse after pulse, against wave after wave of incoming threats, transforming the economics of defense. It's a perpetual guardian, always ready to strike. The true disruptive power of HPM isn't just its speed or its precision. It's the astonishing cost efficiency. While a traditional missile can run into millions, the cost per shot for an HPM system is measured in mere cents. Yes, cents. The only consumable is the energy itself, derived from the platform's power source. This completely upends the economic asymmetry that favors swarms of cheap drones. Suddenly, the defender can engage hundreds, even thousands, of threats without bankrupting their defense budget. This makes mass attacks economically futile. A game changer, indeed. The fundamental difference in targeting strategy is profound. Traditional kinetic interceptors aim for a physical impact, requiring precise trajectory prediction and often leaving behind dangerous debris. HPM systems, by contrast, are non-kinetic. They don't rely on hitting a specific point in space. Instead, they flood an area with enough electromagnetic energy to disrupt the electronics within. The objective is not to destroy the physical shell, but to incapacitate the brains of the target. This makes them incredibly effective against agile, evasive targets, where a direct physical hit is difficult to achieve. The method changes, but the result is the same. Perhaps the most terrifying capability, from an adversary's perspective, is the HPM system's ability to engage multiple targets simultaneously. While a traditional missile defense battery can only launch a finite number of interceptors at once, an HPM system can sweep an entire arc of the sky with its energy. This means that a swarm of hundreds of drones, once an overwhelming threat, can be neutralized in a single, instantaneous burst. The invisible wall becomes a net, catching everything within its reach. This scalability against massed attacks is unparalleled, shifting the advantage decisively back to the defender. This isn't theoretical. Prototypes are already undergoing testing and deployment. The U.S. Navy has its optical dazzling interdictor, Navy, or ODIN, and the high-energy laser with integrated optical dazzler and surveillance, or Helios, both demonstrating directed energy capabilities. Lockheed Martin is advancing its indirect fire protection capability, high-power microwave, or IFPC-HPM. And the Air Force, not to be outdone, is developing systems like Thor, Tactical High-Power Operational Responder, and its successor, Mjolnir. These are not concepts on paper, but tangible advancements. The future is already being built. Where will these invisible shields be deployed? The versatility is immense. HPM systems are being designed for integration onto mobile ground platforms, offering unparalleled protection to maneuvering forces and fixed installations. They can be mounted on naval vessels, creating defensive perimeters around carrier strike groups or critical maritime assets. Even airborne platforms are being considered, extending their reach and adaptability. This means a distributed, layered defense, capable of protecting any asset, anywhere, from the smallest forward outpost to the largest aircraft carrier. The shield adapts to the threat. This shift to high-power microwave defense isn't just a technological upgrade, it's a strategic revolution. It renders mass drone attacks economically irrelevant, forces adversaries to reconsider their entire doctrine of asymmetric warfare, and provides a sustainable, virtually limitless defense against sophisticated aerial threats. The concept of air superiority, once defined by fighter jets and missile arsenals, is now evolving. The battle for the skies will increasingly be fought with invisible energies, striking at the very heart of the machines. The rules are being rewritten, and the implications ripple across geopolitics. Of course, no technology is without its challenges. Storing and efficiently delivering such immense power, focusing the beam with pinpoint accuracy across varying atmospheric conditions, and hardening our own systems against similar attacks are ongoing hurdles. But the pace of innovation is relentless. As these systems mature, their range will extend, their power will increase, and their deployment will become even more widespread. The invisible wall is still under construction, but its foundations are firm. Its potential to transform air defense, to solve the economic riddle of overwhelming threats, is undeniable. In a world where threats evolve faster than ever, the Pentagon's quiet weaponization of directed energy marks a monumental leap. High-power microwave shields offer an answer to the economic and tactical nightmare of swarms and hypersonics. An invisible, speed-of-light energy wall, capable of neutralizing hundreds of threats simultaneously, not by impact, but by intimately disrupting their digital core. It's a defense that is silent, instantaneous, and devastatingly cost-effective. The age of the invisible guardian is upon us, changing air defense rules forever. The future of protection may not be seen, but its impact will be undeniably felt.